Hey guys, welcome back to another RESK problem solving tutorial. And in this tutorial I'm going to be showing you guys how we can invert a binary tree in JavaScript specifically. So inverting a binary tree, this is a pretty standard thing to do, especially when you get onto more advanced Leetcode problems, but this is just the first one in a series of tree problems, so it's an easy difficulty. Don't be fooled though, because if you don't understand how to do it, it can actually be quite difficult. So one thing we should notice is that this has to scale as we add more, as we add height to the tree and as we add nodes. So usually what you can see is, especially for these kind of data structure based questions, recursion is the best sort of idea, because it's going to allow us to easily just recurse through the entire tree and invert the nodes as we go along. So I'm going to be showing you guys how we can implement a recursive algorithm through this tree node, and notice how it's similar to a linked list, except it has a value, but instead of just having a next pointer, it has a left and right pointer. So it's almost like a linked list with two split ends at each node. That's how I like to think of trees. So not that different, but yeah, they come with a lot more sort of overhead functionality. Okay, so we're going to have our invert tree function, and the way to think about recursion is to basically assume that your function already does its purpose, and then we're just going to so we assume that this invert tree function already inverts all the nodes when given its root, and so that's how we function it. So if we assume that invert tree already inverts all nodes, so if we run something like invert tree given root, we can assume that this is actually going to already invert the entire tree for us. So now how are we actually going to run it? So this is what the program's going to call, but then inside of this, if we're assuming that this is true, then what we can do is we can simply just swap the left and right nodes. So we can do something like, using the swap functionality, and I'm going to just leave that there for now, ignore the errors. So we're going to swap the left and right nodes to just the other way around, root.right and root.left. So what we're doing is, imagine we are on this, if we're on like this 4 node at the top, and we just swap the left and right, so essentially we move this 2 over to this side and the 7 over to here. So notice how we've inverted this row over here. Now what we can do is we can call this invert tree function on each of these. So what we're really doing here is we're trying to swap these two, but before we swap them, we invert all the rows below it so that these two are inverted, and then we swap them. So we've inverted all these rows below, and then we swap these. So that's going to work, assuming that this invert tree function is actually inverting a tree. And what we need to do is we need to actually return this node. So we return this root, because once we've swapped the left and right, we want to return them back. So if we imagine what's going to happen now, let me just draw this out here. So we have 4, 2, 7, 1, 3, 6, 9. So 4, 2, 7, 1, 3, 6, 9, like so. And they're connected like so. Okay, so let's imagine we call the function invert tree root and we pass in this initial root. So now root.left equals root.right. Well, let's just ignore that all for now, and we'll look at the left root. So left root is going to be set to invert tree root.right. So essentially invert this entire tree. And we're just going to ignore the sides for now, only look at the invert tree function. So ignore left and right, just look at how this inverts. So we're setting left to be equal to the inverted tree of this, And then inside of here, we go again, set left to be equal to the inverted tree of this, okay? Now, once we get to here, well, if we want to, once we're here, there's actually no child of this, so if we try and call this and try and invert this, we're just going to end up passing none into this. So that's our sort of break condition. We want to check if root is equal to null. And if this is true, then there's nothing to return. So we can literally just return root, because if we just return root here, this is essentially going to set root.left to root.right, but both of these are null. So it's kind of like swapping these over, both of them being null. And so these two swap. Now this has been returned, so we then get this back, and then these two are going to swap, because remember, this is where the swap comes in, left is equal to right, and this has been inverted. So these two get swapped, and same thing happens over here, these two get swapped, and then we go up a level back to this, and now these two get swapped, like so. So now all of this side is over here, and all of this side is over here. And yeah, then we come back to this node, and yeah, that's basically what happened. So when we were here, these two got swapped, when we were here, these two got swapped, and then when we get to here, these two get swapped. And then from there, there's no more recursion depth, so we just end up returning this root. So yeah, that's the basic idea. Now when we return this root, finally this is going to point to this top root, and that's how we end up with inverted tree root is going to give us the correct initial root. So notice how we used recursion to create a really simple algorithm, and yeah, we're just going down and keep inverting the tree until we get to a null, where we just return it. It doesn't actually matter what we return, we can also just return null. But yeah, the important thing is once we get down to here and we try and call it on this, so we call invert tree on this null item, it's just going to return null. So both of these are null, so it's swapping two null items, which doesn't affect anything, and then it just traverses back up the list and swaps everything, which is how it works. It's almost like going straight down and then coming back up and swapping everything on the way up. That's a good way to think about it. Okay, so here's our function. Let's see how this performs in Leetcode. And yeah, hopefully you can get some good time since... Yeah, so pretty average. We are actually using quite a bit of memory, which is surprising. But let's have a look at some of these. So we take that, and yeah, so it's basically the same thing. All we've done is done everything inline, but this is essentially the same algorithm. Over here, left up right, and yeah, so we're just swapping the two. Same sort of thing here, and then okay, so this is slightly different because we invert it. We basically swap them and then invert it. Same kind of principle, but a bit different execution. It seems to have worked better. Let's have a look at the speed ones. Yep, so again, we swap them first, and then we invert the tree below it. Okay. Yeah, so this is actually working slightly differently. In our method, what we did was we went all the way down. Sorry, that's a bad color. In our method, we went all the way down, and then we just swapped them on the way back up. Oh, sorry about that. We swap them on the way back up. As we come back up, we just end up swapping everything. So that's what happens there. However, in this one, what's happening is we start here, and we're going to swap these two, and then call the invert on the items below to end up swapping these, and then we call them on the items below to swap these. And yeah, that might also work. Therefore, in this one, there's not actually any memory usage because we're not returning anything. We're kind of just going down and swapping everything. So this is definitely seems like a faster solution, but it's all basically the same thing when you really think about it. So yeah, this was how you solve Leetcode question 226, invert a binary tree. Thanks for watching, and I'll see you guys in a future tutorial. Bye!